So as Rosario mentioned, I work with no agency and predominantly in the past few years with the National Ice Center. So what they do, they produce ice charts, and as soon as we'll have this thing on the screen, I'll show you what data they use, what satellites they use, and I have no ideas about what security they're using, so that would be left up to you. All right. Okay, so I'll start, that's the title. I'll start with the pretty pictures. So that's how different type of ice looks like. That's an aerial photography. And you may not be aware there are many different types of ice, and it all has to be categorized and charted. So there are multi-year ice, and that's very, very easy to chart because it's more or less in the same place all the time. There's a first-year ice that's much more difficult to detect, and then that's on the upper right. And then the rest of it is extremely difficult stuff. Gray and white, pancake, nihilus, and floats and icebergs. So that's how it looks like from a satellite imagery. Some of them are prettier than the other, but this is all extremely difficult to chart. So these are the hard-to-do cases because this swirly thingy very easily confused with the cloud. And the leads are, which you see on the lower left, on the lower right, depending how you look on there. It's difficult to detect because it's a mixture of water and ice, and it's very much looking like cloud shadows. So these are the, just so you know, that they're difficult cases. There are big communities. So this is one of the Cryosphere Watch page. So they posting a lot of products and the data for download, and also all sorts of news on what's going on in the polar regions. This is a family of satellites that are used. So it's a very busy slide. I did not produce it. I copied it. It may not be up to date. One that I definitely see missing is the new Japanese geostationary satellite named Himawari. For those who speak Japanese, Himawari is sunflower, I guess. And the thing that you need to sort of know about these, because there are many charts with the satellites, there are two different types. One is the polar orbiter, so it goes and it crosses the poles. And these are the closer orbits, and they are marked there in red. And then there's a geostationary, it rotates together with the Earth. So it's constantly looking at the same portion of Earth, and it doesn't see it from the other side. So we have GOES, that's a US geostationary platform. That's obviously looking on our side. Then there is new Japanese satellite, as I mentioned. There is, where is it? Is it, oh God. European Severi satellite, that's a Severi instrument on the EUMETSAT platform that's also looking at the, mostly Africa, actually. They want to look at the Europe, but they have to stay at the, at the orbit that looks predominantly at the Africa. All right, so these are different types of products. So there are many types of satellites, as I mentioned, and there are many different products that they derive. So this is, do I have a thingy to point? I guess maybe that works. What do I press? I don't know. Do I press something?
Take the right.
Whatever. It really will take me longer to figure out. In blue, conveniently in blue, this is new, fairly new polar orbiter. It's a US polar orbiter, and I'll tell you a little bit more about that data very briefly. And the GOES are ABI. It's upcoming. It would be launched in the spring. I'm computer illiterate. I probably can figure it out, but I can't simultaneously think what I'm going to say, look at the slides, and control the multiple hardware devices. So the different types, there are imagers and there are microwave instruments. So as I said, the difficulties is the shadows are confused with the leads and all sorts of things for the imagery. Microwave doesn't see clouds. Woohoo. So microwave is a better instrument in terms of distinguishing the ice from clouds than the visible. And there's also polar night, where visibles are just useless, so they only rely solely on the microwave. And since I just mentioned that the microwave is a better instrument, it doesn't see clouds, and it also doesn't depend on light, so it works at night, and it works during the polar night condition. So why do we have to have a visible? Why can't we just rely on the microwave? Microwave is a much coarser resolution. So the best microwave instruments are 20 kilometer, and the best imagers are 10 meters. Well, 10 meters are not that often, so the overpasses are more rare. But a standard imager is half a kilometer, 250 meters. So it's a much, much finer resolution. So for the ice flows and for the leads, for the finer details in the ice, you don't want to use a microwave. So that's with respect to so here are many satellites. I'll show you how the data look like for just one instrument. So it's not just one satellite, it's one instrument on one of the satellites. Usually a satellite carries more than one instrument because satellites are expensive, so if they're launched, they may as well carry a few things. So there's a raw data file. Now you've seen the whole presentation, I may as well end. There's a raw data file that's called SDR. So those are smaller size. Those are archived and never touched. So there's no modification to those. And there are EDR. These are environmental data record. There are reprocessing done on the environmental data record because there are better algorithms, there are better calibrations, there are better this, there are better that, and better the other. So they're being reprocessed. The raw data record is archived and never touched. So that's the smallest amount. And then it goes as a pyramid. On the raw data, there are many different products or retrievals that are done. So these are the basics for the raw data. Each 86-second granule is what collected, packetized, and shipped to the ground, on the direct broadcast. And then it gets the next 86 granule, and so on and so forth. So it has the geolocation files. It has a higher resolution, the I bands. It has a coarser resolution. It has a unique day-night band. And so overall, these 42 files total 2 gigs for each 86 seconds. For just one instrument, for just one of those satellites that you've seen. So the amount of data that's grind to produce the ice charts is enormous. This is a standard format, so it usually has a file type, the satellite identifier, the date, the UTC, the orbit, the data was created, and so on and so forth. So these are just the formats. These are the difference between these SDRs and the EDRs. I'm not going to go into details. I just threw it in to show you what exists. These are broken down in the file size per type. So the geolocation files are smaller. The actual data is larger. So these are the file sizes. There's different websites from where this data is available. This data is public. It's the environmental data that is available. You don't need to have any credentials to download from most of these. So these are the type of products. So different agencies from all over the world contributing. They have their own charting groups. So it's Canadians, U.S. National Ice Center, and then a whole bunch of North countries. Obviously, that's why they're worried about ice, because they're out there and it matters to them more than to the others. National Ice Center, NIC, is the one I'm working very closely with. This is the system that NIC is using. So with the modern world and with all the algorithms that we have and the apps that you have on your phones and everywhere, they are charting by hands. There are analysts that are sitting in front of the screens. They come to duty every morning. They're getting assigned one of these regions. This is the chart for the Arctic, and there's a similar one. So they have a region divided. They get assignment in the morning which region they're charting. They have an access, so this is one of the systems they have. So they can collect which particular granule they will choose, because one will have more clouds than the others. They can't look at all of them. They will selectively look at some, and they will bring portion of previous day chart for the multi-year ice that they trust. So they're only going to do certain regions. So that's how they're drawing. And they're producing, after all, this ag. I don't have a thingy to point, but you see the ag. Ag has the symbols. So 8 to 9 is the solid ice, and then it goes down to the fractions. And they finally output, so they have this menu where they're selecting the ice concentration, so they drop it on the ag. Again, I'm not going into details how it's all going to look like, but they're saving it in shape files. So one of the shapes you see drawn here. So they will outline, and this is a pancake ice, so they will put a particular label for the ice concentration and the marker what type of ice that is, save it, the daily products available at NIC every day by 1 p.m. So that's how it looks like. So that's what they produce every day. It's the shapefile, and it has all these ags with the symbols, and that's what is being published, and that's what's being used. So different agencies producing different ag-looking charts. So this one is from Alaska desk. They also have their analysts that are sitting and drawing, but it's slightly different symbolic system. So you have to be also aware that different agencies are drawing it in a different form. There's no standardized format for the ice charting. Users. So these are just a standard, users that would be interested in the ice. It's the weather prediction, obviously, transportation. They need to know where to send ships, and less obvious hydrological modeling. A whole bunch of modelers are using this data, and obviously climate monitoring and analysis, because there's a lot of ice there. It's melting. Manhattan is an island. That might be a problem. So these are the charts for the ship navigation. So this is what they're learning when they're about to become captains on the icebreakers. They need to know where to go and where not to go. So these are different things from just the handout. Because if what you see on the right is when they're happily cruising, some of the smaller, younger ice is not a problem for them. But example on the left is the ship that's stuck in the ice, and it just sits there and waits for icebreaker to come and rescue it. And these are other users in the Arctic community that are benefiting from analysis of climate and just the regular ice charting. That's all I have.